Hello, welcome to the Virtual Beach video tutorial series. These tutorials were created with the support of both the University of Wisconsin Sea Grant Institute and the Great Lakes Observing System. My name is Sonia and I will be leading these tutorials. At the website virtualbeach.org, you will find all of the video tutorials, many helpful hints, and links to data sources. The 3.0.6 version of the Virtual Beach software will be used in these tutorials. Download and install the Virtual Beach program before proceeding. A link to the download page can be found at the top of virtualbeach.org. The link takes you to the United States Environmental Protection Agency where you can download the software. These tutorials are intended to walk you through the Virtual Beach software that was created by the US EPA. Virtual Beach is a predictive modeling program that can assist managers in making advisory decisions at fresh and saltwater beaches. With this software, beach managers can create models to predict bacteria levels at a beach. This tutorial, Data Preparation for a GBM Model, walks you through the second of 6 modules demonstrating how to use the Virtual Beach software. If you have not completed the first tutorial, please do so now. You need to use the project file created in the first module, Beach Orientation, for this current tutorial. If you would like to proceed without determining the orientation of a beach on your own, you can download the demonstration project file from the Virtual Beach step-by-step training modules page. The demonstration file is contained in the zip file found in the first section. You will also need to download the data file VB Training Data GBM to your computer. A link to this file is in the second section, Preparing Data to Create a GBM Model. Save the file where you can easily locate it when in the Virtual Beach program. Detailed directions for this module are available at virtualbeach.org in the training section. Under the subheading Virtual Beach Step-by-Step Training Modules, select the Data Preparation-GBM PDF. Either open the PDF on your computer or print it so you can follow along with these instructions. By the end of this module, you should be able to import and clean up model building data for your beach, process directional data such as wind, currents, and waves, combine 2 or more predictive variables, and transform the dependent bacteria variable. Preview the data you will be importing into Virtual Beach by opening Microsoft Excel. In Excel, open the file VB Training Data GBM. The worksheet GBM Model Building Data 2009-15 contains the data used to create the model in this tutorial. Note that column B is always the response variable, E. coli in this example. All data to the right are potential explanatory variables. Definitions and sources for each potential explanatory variable can be found in the Key worksheet. The worksheet GBM Validation Data 2016 will be used in the next module to validate the model you create in this tutorial. Close the Excel file before returning to Virtual Beach. Data cannot be imported from an open Excel file. When you create a model in the future, be sure to save your data as XLS files. A plugin for Virtual Beach is available for importing XLSX files, but there are still bugs to be worked out. Now open the Virtual Beach program. Next, open the file you saved during the previous module, Beach Orientation. Then click on the Location tab to see your beach. Note, sometimes the beach orientation appears as 180 instead of 21.15. The water is marked correctly, but the number is wrong. If you click Remove Water Marker, then click on the water in front of the beach area, and finally click Add Water Marker, the correct beach orientation appears in the box. Now click on the Global Data Sheet tab. Click the Import Data icon. Select the Excel file VB Training Data GBM and click Open. In this example, there is more than one worksheet in the Excel file, so you must choose which one to import. Select the worksheet GBM Model Building Data 2009-15 and click OK. The data table opens and Virtual Beach automatically highlights the second column of the datasheet as the response variable. E. coli is highlighted here. The response variable is indicated in the left-hand panel along with column count, row count, and other descriptions of the data. Virtual Beach will not build a model if any cells are blank or have text values. Models can only be built when every cell contains a number. Now, click the Validate Data icon to check your dataset. In the pop-up window, click Scan. In this tutorial, the CloudCov Qual column is flagged because the values are text or non-numeric. Click the radio button next to Delete Column. Under Take Action Within, make sure only this column is selected. Click Take Action. Next, the column Trib6 will be flagged. The variable is numeric, but some cells are empty. Do not remove the entire column. Instead, click the radio button for Delete Row. Select Entire Column and click Take Action. All rows with empty cells in this column are deleted. Repeat scanning until a notice appears at the bottom of the pop-up window stating No anomalous data values found. Then click the Return button. Now it is time to process the wind and current data. Click the Compute AO icon. In the pop-up window under Wind Data, click the pull-down arrow next to Speed and select WSPD. For direction, select WDIR. Repeat for the current data, selecting CSPD for speed and CDIR for direction. Repeat again for wave data, selecting WVHT for height and WVDIR for direction. The beach angle is automatically included. Click OK. Scroll to the far right end of the table. 6 new columns have been added to the end of the global data sheet. Wind A comp, alongshore wind speed. Wind O comp, toward shore wind speed. Current A comp, alongshore current speed. Current O comp, toward shore wind current speed. Wave A comp, alongshore wave height. And wave O comp, onshore wave height. Note that the unprocessed wind, current, and wave data columns are now inactive as indicated by being shown in red text. Now, you can combine 2 or more predictive variables. Click the Manipulate icon. In the pop-up window, Control-select TribMax24 and TribMin24. Then click the right arrow button. Click the radio button next to Difference. Click the Add button. The change in flow variable diff TribMax24 TribMin24 has been added. The difference between 24-hour maximum and minimum flow rates is an indication of whether recent tributary discharge has been consistent or very different after a flash flood event, for example. Since the expression has been added, remove the 2 variables by shift-selecting TribMax24 and TribMin24. Click the left arrow button to move the variables back to the main list. If desired, you can create other expressions of combined variables. When you are done, click OK. Scroll then to the far right end of the table to see any new columns added through this process. The last step for data processing before creating a GBM model is to transform the dependent bacteria variable. Log 10 is a common transformation for microbial concentrations. Right-click on the E. coli column header and select Transform Log 10. The logged values appear in the column. Now, save your project file with a distinctive title. You are now ready to move on to the next module, building a GBM model.